This is the Quality Grind podcast presented by Medvacon. Conversations that go beyond compliance. Sharing insights geared toward helping you navigate the everyday grind of regulated life science industries. Here are your hosts, Joe Toscano and Mike Kent.
Welcome back to The Grind, everyone. In today's episode, we continue our visit with Jose Mora by outlining 7 specific benefits of applying lean principles in regulated life science environments. We'll also talk about how lean can optimize R&D activities and reinforce the principles of good science. Let's rejoin the conversation as we dive into those 7 benefits of lean. In a recent blog that you authored, and we're in the final stages of putting that together for publication, you had mentioned there were 7 aspects or 7 points that lean can assist with in regulated life sciences. Those are quality and compliance, throughput and operating expense reduction, speed to market, flexibility and adaptability, continuous improvement, risk management, and customer focus. So what I'd like to do is just have you talk a little bit about how lean principles can help each one of those 7. And first off, and it's probably the $64,000 question, how can lean specifically improve quality and compliance?
So quality and compliance is about meeting standards, meeting specifications, and also about having the proper feedback when something is deviating. So in a regulated industry, we have the feedback of the customer complaint, but we also have the feedback of the nonconformances. However, the length of time of that feedback has a lot to do with the success of lean. So if that feedback comes back immediately, you can course correct immediately. The idea of lean is also about having the smallest, ideally a lot size of 1, and immediately sending that to your next step and getting feedback. Was this good? Yes. Was this good? Yes. And that establishes a chain of assurance, of quality assurance. The real quality control is that feedback mechanism. Saving everything for a final inspection when you've got a huge lot of material, you shouldn't have to do that. By then, you should already know that it's good product.
If I can, follow what you're saying there, you mentioned a couple things. One being a lot size of 1. That may be a lot easier to do to minimize your lot size in a medical device environment, but in a pharmaceutical environment, when you're dealing with, 500 liter batches of biologics, for example, or, a lot of 1 million capsules or 1 million tablets or something along those lines. And I can hear the naysayers saying, well, that doesn't apply because my lot size can't be one tablet. But at the same time, let's think about this for just a quick second and go down that rabbit hole. Where can you get those points of feedback that are critical to the quality of your product? I would call those critical control points in your process. If you establish a mechanism to get feedback there, you can minimize quality control testing, the finished product testing at the end of that process, which tends to be a real rate limiter in terms of getting product out the door.
Yes. And there's a very important point here. And we need to think also of the speed at the bottleneck, because not all production steps are equal. And what ends up happening is whether, we immediately think, oh, a capsule is 1 lot. Well, not really. A capsule, if you think in terms of here's how much I produce each minute or each hour, then let's talk in terms of that. So if you've been producing for an hour and you have no feedback and you produce for 8 hours, you may have produced 8 hours worth of junk. And I don't care if you're talking about 1 million tablets or you're talking about 50 medical devices. or one CT scanner. It doesn't matter at that point. It's how much work have you done before you have some feedback where you can correct your course. And one very pertinent example, when I was working with breast implant manufacturing, one of the steps was you dip a mandrel into silicone, and that mandrel has to go through a curing process that takes several hours. And you won't know what comes out of that until after the whole curing process, and by then it's too late. So one of the things I was told is, oh, well, you can't apply SPC there. Well, yes and no. First of all, you can be monitoring your process parameter, your heat, humidity, cycle time, the quality of the mandrels, and also as things are coming off of the final curing, you can do some inspection. Now, the feedback loop may not be optimal, but at least you're getting regular feedback. So in a case like that, I think of a giant Ferris wheel where one person's getting on, one person's getting off. And if there's something wrong with a Ferris wheel, at some point you're, hey, you know what, you still have some time to react to it, even though there is a lag. So don't use the lag as an excuse to not do this. Okay. Is my message. So, there are all kinds of ways around it. And if you think in terms of a pull system, then everything lines up. So in the Ferris wheel, you're always one person's getting off, one person's getting on. And as long as you keep that going, you'll get some feedback on how the ride is going. So similar to the process. In the case of the curing of those implants, you will eventually know, hey, something's starting to drift. Now, yes, unfortunately, it may be several hours of work, but it's better than several days of work. And so, and this was many lessons learned there also. But the point is that the quality, there's two types of quality. There's inspection of the product, but also inspection of the process. And this is the heart of process validation. Heat, humidity, time, tooling, keeping an eye on how those are going, and replacing things on a timely basis. So this talks to both process controls and product inspection. And having those lined up and frequently communicating is part of the essence of lean.
That makes a lot of sense. And it segues really nicely into the second point that you mentioned is throughput and operating expense reduction. So I think you're right on that same line. Anything unique that we haven't talked about in terms of benefits of lean?
Yes.
But OEX, yeah.
This brings me back to when I was doing lean transformation at a pharmaceutical, and even people who are very seasoned in theory of constraints, this is confusing to them. We had two product lines that happened to share one bottleneck. So different types of tablet products. So the theory of constraints is, well, you never want to let your bottleneck starve. So you have to keep, let's say, 4 lot units buffer in front of it. Well, the debate was about, well, I got to keep that buffer there at all times. And what I was trying to say, well, wait a minute. If you have 4 lots of product A and you didn't put any of product B, you're going to have to let product A work through that bottleneck before you get the first unit of product B. So when you're dealing with 2 lines that are sharing a common constraint, it's not just about protecting that buffer. It's also about protecting the 2 lines. And in that case, I would have said A, B, A, B, so that the furthest distance from passing through the bottleneck for any one of those products would be 1 lot of anything. Okay, so if you had 4 of product A because you happen to get productive, well, all of a sudden, hey, I need product B. Oh, sorry. We got to go through 4 bottleneck cycles before you get anything. And all of a sudden, your downstream process is down. So in theory of constraints, we tend to think linearly, which is a good thing. but we need to consider when there are shared resources, especially at a bottleneck. And this is why signals are so important, because if you're pulling, it's going to say the next one needs to be A, the next one needs to be B, A, B, B. And if you have, that's a drum buffer robot. So as you're pulling, the signal, the drum is saying, okay, I need A, I need B, and that way you're always having staged up the next one that you're going to need. There will be no surprises.
Because you've sequenced that and you've programmed it rather than rely on the predictability of process A and process B to continue.
Right.
That push mode where you're reacting to, okay, what do I have? And then now what do I do? Rather than saying, I need, therefore I'm going to pull. I'll pull A, then B, then A, then D, because that makes sense for what I need.
Right.
You set your process up that way. Okay. I feel like I'm getting a little bit of a here in process engineering, which is always great.
So going back to the same pharmaceutical situation, there was a group of lean experts, and again, they were thinking linearly, and it's okay, they optimized the whole tablet and capsule process. Well, if you think about it, pharmaceuticals has a surprise for you at the end. You have pouches, you have bottles, you have jugs, you have all of these things are feeding into 20, 30, or even 50 different product presentations, even though they are the same tablets and capsules. Because depending on who the customer is, you might only want 30 aspirin, you might want 500 aspirin. So all that work they did got completely diffused at the end, because how do you predict packaging when you have all these different product presentations? So you have to really understand your process and understand where it's going to diverge as well as where it's going to converge. And this is why process mapping is so essential, because you need to do a simulation, visual and practical, to really see what's going on. And those are two big misses that happen in real life. And it was embarrassing because these were people that knew theory of constraints and knew lean, and yet they fell into these two traps. So that's a free example right there.
Yeah, I think it's a great lesson on a couple of different levels. One, we can optimize a process in what we view as a process, which is really just one portion of an entire operation. And impact of anything that we do upstream or downstream needs to be assessed and should be assessed concurrently. So I think that's a great reminder to us as well in terms of that throughput. And all of this that we talked about really goes towards, if you are reducing downtime, if you are improving quality, if you are eliminating or reducing steps or the rigor involved in any sort of activities through that process, you're going to decrease your operating expense. The next one you mentioned is speed to market. Tell us a little bit about that in terms of getting maybe a development product or even a commercial product out to market and benefits of lean. I think it may be obvious, but I'd love to hear you articulate it.
Yeah. So the speed to market, one of the problems is that we don't do enough rigor at the beginning of identifying user needs, identifying design input requirements, because that's not very, very satisfying. It's not very sexy. It's like, let's just get it out the door and get some feedback quickly. And yes, you will get feedback quickly, but it may be embarrassing feedback because you forgot some very basic things. So taking a little bit extra time to go and talk to your customers, observe them in real life, because very rarely is an invention something completely new. It's like, oh, wait a minute, I know something else somewhere else that we could apply here. So we're constantly in tune with everything around us and we remember things. So when you're doing a product and you're thinking, you've got to put yourself in the shoes of the user and understand what their world is like. And an example that comes to mind is, okay, I need an alarm that's going to tell me, hey, beep, beep, beep. And you're doing this alarm in the lab and it works perfectly every time. Well, now you put that alarm in the operating room or the emergency room and you've got 10 other devices going beep, 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 the same beep, visual, audio, and you have no idea where it's coming from. Well, it worked perfectly in the lab in isolation, but now in this complicated customer environment, I'm going crazy hearing all kinds of beeps and buzzers. I'm dealing with 10 different patients. So I have to be able to distinguish which alarm I'm hearing. And all of a sudden, you have a very different situation. The other thing is, what if that operation is happening in an air ambulance or is happening in Denver, Colorado, or La Paz, Bolivia, or somewhere right on sea level? Altitude plays a huge difference. So you have to take in the totality of the customer experience, and there's already plenty of information out there. And if you look for it, you can channel it in and build it into your user needs, design input requirements. And if you do that methodically, you're not inventing things. You're simply leveraging the big data that's out there. So by the time you do your design, you're working with that knowledge. And while everybody hears about, oh, the Eureka, I've got this invention that's going to change the world. And while that may solve one problem, unless you understand the real situation that you're trying to improve for your customer, you might solve one problem and create 5 new ones. So that's why this is why I keep saying situational awareness. You need to understand who it is that you're supplying this to and what their world is like. And the anecdote of selling refrigerators to Eskimos comes to mind. You need to understand their world before you supply them. Do they have the supply chain available? If they need to repair something, can they get it repaired? Spare parts. And that's what avoids embarrassing mistakes, because there could be many cultural things, there could be situational things. So speed to market is not so much about the sequence of the design control process. It's about being present and aware at each step and thinking through it and getting the right people involved at the right time.
Yeah. Well, it takes that one step further. We get so caught up in doing things, again, it's a constant theme, right? Doing things fast. And we have 3 months to get this out onto the market. If you get, something out onto the market that fails to address an important customer need that you've mentioned, a whole laundry list of great examples, then you haven't made it to the market, because your product is going to go back to be reworked because of that. And now you have an entire change process that you have to navigate.
Right.
I want to go back to this in the context of the point you made really early on, that planning and needs assessments and all of those things that you need to do up front aren't sexy. But here, doing those things well gets us to market with a product that will sell and will be viable and safe faster than it does trying to do that process fast and missing something that eventually means you got those things.
And another saying that resonates with me is, in the age of information, ignorance is a choice. You can't just sit there and say, oh, I didn't think about that. Well, if you, never mind the internet, you have AI now, and you can say, tell me about all the customer problems with this kind of product, and you'll immediately get a flood of information. So it's not lack of information, it's not lack of time, it's lack of critical thinking and lack of presence of mind. That's what's really hurting you. That you're only thinking
on the end result. Yep.
Yeah, you're just focused in your own little silo. Well, we did this last time, so therefore we're just going to plug in the same user needs that we did last time. And well, you forgot that was 10 years ago, and the world has completely changed in the last 10 years, the last 10 months, the last 10 days, never mind.
Sure.
And you're thinking with the mentality of what was true 10 years ago. No, there's no excuse for that. And that's why that goes back to the saying, you're not the same man, you're not stepping in the same river anymore.
One of the things that I think that discussion points to rather well, and I'm going to combine the next 2 points, really they are around flexibility and adaptability and our willingness to continuously improve and really do continuous improvement. So, can you summarize a couple of points where lean really hits flexibility, adaptability, and continuous improvement hard and makes those things possible?
The flexibility part is, I'm thinking of the customer's flexibility, the supplier's flexibility, and also the flexibility of the operators. And you have to consider their world. And I probably mentioned this anecdote before. I optimized a blow molding and heat set process for angioplasty balloons, and I personally operated it. So I got it down to a science, and then I put the operators to do that, and they didn't like it because they wanted to be sitting side by side while the process was running and chatting about chicken recipes and family while the process was running. And I just disrupted their whole social network because I turned it into a one-person efficient operation.
It's no wonder engineers get the reputation that they do, right?
Yeah. So the other thing is you give people a microscope to inspect. Boy, do they love to crank that up. They'll crank it up to 10,000, and they'll find defects that are totally inconsequential. So you have to adjust. You have to tell them, no, this is what we're inspecting for, not whatever these. You have to align. So you have to be flexible in terms of what happens when you implement something. You think you have a solution, but you have to take in the social context and the other signals, make sure that the operators were part of the solution, get them involved. The same thing with the customer and the supplier, understand what's driving them, what's keeping them awake at night. They may have a particular component that's a critical component, and they're having trouble getting it. Well, you need to know that. If you don't know what their world is like, and what may be inconsequential to you, might say, well, you've been giving me 5 at a time, I want 10 at a time. You may have just changed somebody's entire production line without knowing it. So flexibility is alertness and awareness and communication in your supply chain, and also with the people on the production line as well as the people supporting it. So again, lean is always about signals, communication, and frequency of timing.
Hearing you talk about all these things really brings me back to making good decisions based on those signals and understanding the impact of not only how things are going, but potential impact of changing things or that flexibility or the improvements. As you just mentioned, you make one change in one place, you may have disrupted everything upstream or downstream. So the 6 elements that you mentioned in the blog is risk management. And this is a topic that we can spend hours, days, months, and many people have out there. It's certainly an area of focus in the regulated spaces now. But how does lean help us improve the quality and rigor of our risk management practices?
Oh boy, I almost feel like you were at my meetings yesterday.
Well, you're watching my house operation and my lack of preparation, so I just turned the tables.
So lean is also about discipline and focus. And we were developing this user task list, and every step was, okay, operator, and the operator does this, operator failed to do this. Well, operator failed to check for damaged packaging. Operator failed to check for cracked, for leaking. And I'm like, wait a minute. This isn't an operator error. This isn't a user error. These are design defects and process defects. So one of the disciplines in risk management, if you're doing a design FMEA, you're assuming a perfect process, because you really want to focus on true design defects, not that somebody forgot to change the tool. That's a process defect. Right. Likewise, when you're doing process, focusing on strictly process, you're assuming a perfect design. Now, at some point, you need to bring that all together, but you have to, when you're doing detailed work, you have to really concentrate. And in a prior job, I started to do the same thing. Oh, the user did this, and there's no. Somebody pointed out to me, these are not the user's failure. These are the design failure. So you have to really focus on user error. The user picked up the wrong product. The user used the wrong technique. Okay, those are user errors. The user could not see the product. That's a design error. So you have to, in risk management, you have to have that discipline, and you also have to be cognizant of risk versus benefit. And X-ray, by definition, is going to expose you to radiation. That's the way it's supposed to work. Okay, but the benefit is that you get a clear image. Well, you need to understand that, the risk-benefit equation, and at some point determine what is an acceptable risk for the given benefit. So risk management needs to be taken seriously. And the reason people avoid it is because, it used to mean 5 people in a conference room arguing or doing routine stuff for a whole week, and they drive each other crazy going through each step by step. Well, guess what? Newsflash, we have AI. You can actually ask AI, tell me everything that can go wrong with this process, and they can lay out 90% of what you're doing, and then use those people to now clean it up. Now, you can't go on autopilot. You have to know what you're doing. But a lot of this routine
out
stuff,
there. Yeah.
There's a lot of tools out there now that can make the risk management flow move a lot faster, a lot easier, and bring to your attention things that you may not have been aware of because you've been living in your own little world. Well, now there's big data out there that can bring things to your attention. So risk management, this is a great time to be alive in terms of the ability to do things with risk management that you couldn't do before.
Yeah, and I feel compelled just to throw the public service announcement, and let's temper our expectations in use of artificial intelligence. There still has to be a human involved, especially evaluating the output. The last of our 7 benefits or points that you brought up and that we want to focus on is probably the most important one, and that's customer focus. And for us, being regulated by scientists, that ultimately means a patient, someone who is going to either use or consume the end product of whatever it is that we're manufacturing. So how does Lean help us do better with regard to customer focus specifically?
Well, the first thing that comes to mind is that as you learn from customer feedback, if you have a lean design control process, you can solve the problem faster. And one of the things that typically happens with medical devices is initially the device is designed for a clinician, a doctor or nurse, to administer that in a clinical setting. So we're simply assuming, okay, this person knows how to do this. They know how to use this. Later on, the product moves to home use. And now you have maybe an elderly person, maybe a restless teenager, and they're going to use this product. And they may not either have the patience or the manual dexterity to properly use the product, nor the knowledge of a doctor or a nurse. So this is where the lean flow of communication and information can help you get ahead of those issues and understand your customer, what they need, and let them communicate. one of the things that drives me crazy is a company sends me, well, how was your experience at the last time? And I'm thinking, well, you're gonna count my good experience, and you're gonna use that to mask all the bad experiences. A lot of times, you know what? No, I'm not gonna do that, because I need you to listen to the bad experience and react to it. And a lot of these companies, every time you order, like, oh, how did you like it? How did you like it? Well, 99% of the time it was perfect. And what I can read right through that, okay, you're going to use that 99% against me to say, well, 99% of the time you were fine. I don't care. You messed up that one time. And, if 99% of planes landed, well, that's 99% of ambulances got the patient to the hospital. Well, guess what? That one time makes a big difference. So real communication is not just about sending out blind surveys or saying how, like you're saying, hey, my door is open. Real communication shows up when that manager that told you that, oh yeah, quality is job one, and next thing you know, you see him flush red, pounding his fist on the table and telling the quality inspector, stop rejecting so much product. That is the one time that he just undid all this other wonderful blue sky stuff about quality is job one. That one time.
Absolutely.
So you have to be very mindful of the message that you're sending.
Yeah. Are there unique characteristics of research and development, R&D or product development that Lean could apply to? I'm thinking about companies that are just doing development right now, but are not selling any commercial products. How can they benefit from Lean?
At a high level, if you really understand Lean, it shouldn't matter which environment you're in, because the principles are identical. One of the problems that happens is there's people in the R&D world that say, well, I just want to experiment. I don't want to I don't want to be held to any GMP requirements. I just want to crank out a whole bunch of stuff. And my challenge to them is, if you make one prototype then that was successful, you really like, would you know how to make a second one? Did you write down the settings? Did you write down the materials? If you had to send it to somebody else, would they be able to duplicate what you did? If you didn't, then you are hurting yourself, because you may have found the perfect recipe and it'll never exist again because you didn't record your steps. So don't worry about it in terms of GMP and regulation. Do it for your own needs. And one of the favorite sayings of validation is, once is a miracle, twice is a coincidence, three times a validation. And the reason we want to do that is, if you can make 3 of them in a row or 3 lots, yeah, you kind of know what you're doing. So in research, it is important not only to try new things, I think that's great, but let's try them in a way that they're reproducible, and let's control what we're changing. And this is where design experiments comes in. If you tweak the heat and the pressure and temperature, do that on purpose, create an orthogonal array, challenge the process and product in an organized way so you have repeatable and reliable data on which to base your next decision. And unfortunately, too many people have the mindset, oh no, I just want to play. I just want to do whatever I want, and I'll let you know. And then when I have it, don't touch it, because I don't know what I did, but just don't touch it. And
I can regurgitate all the details to you because I did it. So in that case, Jose, what specifically about Lean and those Lean principles can help that development scientist, that research scientist, that research engineer do what we want them to do and what they should do in science even better? What are the specific applications of Lean they can leverage?
Well, first of all, think from the end to the beginning. What is it that you're trying to accomplish? You're trying to satisfy a need. How will you know when it's done? Work backwards to map the steps you're going to do, and what assumptions are you making that may not be true. If you want to make 3 of them, that's fine. You don't need to make 300 of them. You didn't need to order a 5-month supply of material when all you needed was enough for this. So So the lean is focusing on what am I trying to accomplish? What are the steps? Where's my bottleneck? What is it what supplies I need? And there's a concept there's a book called Rules of Flow by Efrat Goldratt, and it says full kit. If you go into the lab without a full kit, you're going to walk right out because you forgot your beaker, you forgot your drill, you left your tools in the car. So a full kit is, as you're going to do this, whatever you're going to do, make sure you have all the materials and supplies ready before you start doing your stuff. So lean is also about having a checklist of, do I have everything I need? Do I know what I'm trying to do? Okay, now let me play. Let me play in an organized, repeatable way. And that's not about compliance. Do it for your own reasons. And by the way, yes, it is about compliance, because unless you do that, you cannot claim anything. But again, sure, if you make compliance your goal, your only goal, you're going to fail. If you do it for your own reasons, for your own process efficiency and your own goals, you will most likely be compliant.
Yeah.
So,
and on this show, we stress time and time again that compliance, or as you put it, if I'm aiming to comply with something that I'm going to naturally be working against or towards some form of resistance until I get there. I almost fell out of my chair as you were describing. Well, map out the process of what you want to do, design your experiments, gather all of your materials and have them all in one place so you know where they are. You have just enough for what you need to do, and then go play.
Another anecdote. One time I was in Miami in the backyard talking to a painter, and in South Florida, color is very important because you have a lot of weather pattern and paint color fades. So we got into the conversation about lot size, and he said, the bad painters, they'll make a huge batch because they don't know what they did, and they want that batch to last through the process, through the entire time. The good painter, they know exactly how to mix a paint to get the exact color. They're not worried about that. They'll know how to create that exact color because they control their process. And I'm like, wow, this guy really knows his stuff. So
there we go.
This was a professional painter who basically validated what I've been trying to talk about in manufacturing. Another anecdote I wish to share, and I go to Starbucks every so often, and I like to order egg bites, and every time I know exactly who made it because the egg bites are upside down. And this is not a careless person. This is a very reliable, methodical person. Many people have the idea of proper product placement. This person is not one of them. But she consistently has been making these upside down for the last 2 years. And I don't want to embarrass her and say, hey, by the way, it's too late. It's been 2 years. And, I just take my fork, flip them over. Okay, but the point is, here's somebody that's an experienced person right under the eyes of the manager. It's the last person to see the process. They're shipping a defective product out the door. The customer's too embarrassed to say anything. The boss never checked the work. Nobody ever trained her that one time to say, hey, these go this way. And she's been doing that consistently. Now, this is very insignificant. Fine, they're upside down, no big deal. But what if it was something important in a medical device and it was the last step and you don't know about it because... So that's just something to plant in somebody's head, that you need to keep checking in and sample, eat, like they say, eat your own dog food, every once in a while, be your own customer and see what the experience is like. So.
Absolutely. And I think that's a great way to wrap up our discussion on lean principles and regulated life sciences. Really, some of the messages that stood out for me, Jose, is, good planning, understanding your process, really doing the upfront work in a rigorous, diligent way seems like it's going to take a lot of time and take a lot of energy. And we hear it all the time. The investment up front will come back to you tenfold in effectiveness and efficiencies and everything else if people are disciplined enough to go through the rigors up front. These are just good reminders of all for us. So thank you so much for sharing a little bit of your knowledge and expertise in this area with us this morning. We encourage folks to check out the other Quality Grind podcasts. Once again, those are episodes 19 and 20, Lean Principles of Quality Control Documents. They are a must listen for folks who are interested in improving the effectiveness of the documents that we use in regulated life sciences. And we'll continue to have Jose on the show to talk more about lean principles, because really they do apply across the board with some deeper dives. Jose, thanks so much for being a part of our conversation this morning. It was great to have you on, and we'll talk to you again soon.
Thank you. And I have to admit, I enjoy doing this. So you've been warned.
Well, be careful what you wish for. We certainly enjoy having you, and we'll do it again.
Thank you.
Thank you, sir. Be well.
All right. Thank you.
If Medvacon can help you and your organization, we're happy to do so. We specialize in the following areas: quality and compliance, validation and qualification services, project management, tech transfers, general and specialized training programs, engineering services, and talent acquisition. If you have general questions as well, feel free to give us a call at any time. We can easily be reached at 833-633-8226 or via our website at www.medvacon.com. Thanks so much, and we look forward to speaking with you.
Thank you for listening to the Quality Grind podcast presented by Medvacon. To learn more or to hear additional episodes, visit us at www.medvacon.com.